Hello everyone, and welcome back. Today, I want to take you on a journey not just across the solar system, but across time itself. Because the story of 3I/Atlas, the interstellar visitor now drifting through our cosmic neighborhood, did not begin when we discovered it in 2025. Its true story began billions of years ago, in a time before Earth even existed. When astronomers first detected the faint reddish object on July 1, 2025, nothing seemed unusual. Another distant traveler, perhaps a long-period comet disturbed from the Oort cloud. But within days, its trajectory revealed an unsettling truth. This object did not belong to our solar system at all. It was moving too fast at too steep an angle, along a path no gravitational model could reconcile with any known origin inside the Sun's domain. It was interstellar, only the third such object ever identified. And yet it was unlike the two before it, Oumuamua and Borisov. Its optical color resembled the distant trans-Neptunian objects beyond Pluto, but its chemistry quickly proved far stranger. Early spectroscopic measurements hinted at a cocktail of carbon dioxide, carbon monoxide, water vapor, and complex carbon-bearing molecules. If this had been any ordinary comet, these ratios should have been predictable. But they weren't. They deviated so sharply from solar system norms that researchers began quietly comparing Atlas to a rare class of meteorites known as Cr carbonaceous chondrites. Fragments of ancient material rich in organic compounds, amino acids, and prebiotic chemistry. These meteorites may represent the most primitive building blocks of life ever found on Earth. And now it appeared an object from deep interstellar space shared their signature. But the real shock came not from its chemistry, but from its timeline. Using the Gaia DR3 stellar catalog, scientists reconstructed its inbound path and discovered something astonishing. For at least 10 million years, Atlas had not passed close to any star, not even once. For 10 million years, it had drifted silently through the cold, unlit void between systems, gathering cosmic dust, accumulating frozen volatiles, and enduring relentless galactic radiation. Imagine an object older than Earth, older than the Sun, older than the solar system itself. Wandering alone with a memory etched into its surface, the memory of environments no human has ever witnessed. But interstellar silence can be deceptive. Objects like Atlas behave very differently from comets born within our system. Solar system comets have warmed and cooled hundreds of times as they loop around the Sun. Their surfaces have been baked, fractured, and reshaped by countless passes. Atlas, by contrast, was a pristine time capsule, untouched, unprocessed, carrying unaltered material from its birth environment billions of years ago. Some even proposed that its outer shell might be coated with exotic compounds produced only in the interstellar medium, where cosmic rays break and reassemble molecules into increasingly complex organic forms. All of this would have been thrilling enough. But then, something completely unexpected happened. As Atlas approached 2.5 astronomical units from the Sun, a region where water ice can begin to melt or sublimate, it did something no comet should do. Within just a few days, it brightened by 2 full magnitudes. Normally, cometary outbursts fade quickly. This one didn't. Instead, the brightness stayed elevated and then increased further. It was as though the entire surface of Atlas had awakened at once, releasing gases, dust, and plasma in a global eruption. This was the first clue that Atlas was experiencing what some researchers now call global cryovolcanism. Rather than venting from a single fissure, its entire crust appeared to be reacting, a sign that its surface had spent millions of years accumulating volatile material that was now suddenly exposed to strong solar radiation. The conspiracy-leaning corners of the internet began whispering, was this a controlled event? Was Atlas reacting to the Sun in a way that suggested design, not chemistry? But the scientific answer, though less dramatic, was far more awe-inspiring. Beneath its fragile outer shell, likely lay metal-rich layers containing iron and nickel. When heated, these could catalyze reactions that produce magnetite and complex organics reactions that may mirror the very processes that helped seed early Earth with the ingredients of life. In other words, Atlas might be performing the same chemical choreography that occurred in our solar system 4 billion years ago. And if that was true, then observing it wasn't just about tracking a comet. It was about witnessing the ancient recipe for life replay itself in real time. By the end of September, astronomers worldwide were asking the same question. What exactly is Atlas a comet? A fragment of a shattered planetesimal, or something far rarer, an interstellar seed forged in another star system and carrying inside it the molecular possibilities of life? The answers had only begun to surface, and the closer Atlas drifted towards the Sun, the stranger the story became. But if the awakening at 2.5 AU was the first shock, what happened next raised even deeper questions. As Atlas continued inward, scientists expected it to gradually brighten, release gas, and behave like a normal comet entering the Sun's heat. Instead, its activity escalated in ways that defied every model ever built. What mechanism could cause an object dormant for millions of years to erupt across its entire surface? And why did the eruption seem so coordinated, almost rhythmic? One possibility, scientific and yet strangely poetic, is that Atlas carried a fragile outer crust saturated with ancient interstellar ices. When heated, these ices may have vaporized simultaneously across the surface, producing bursts of cryovolcanic jets thousands of kilometers long. But even if that explains the sudden activity, another question lingers. Why would such volatiles survive intact for so long in the harsh interstellar medium? Shouldn't cosmic rays have shattered them into dust long ago? Perhaps the answer lies deeper within Atlas's metallic core. Spectroscopy revealed elevated amounts of nickel and iron materials that in meteorites are known to catalyze organic reactions when exposed to water. Could Atlas, as it warmed, have triggered chemical processes similar to those that occurred on young Earth reactions that generate amino acids, sugars, and nucleotides from simple molecules? And if so, what does that say about the universality of prebiotic chemistry in the cosmos? For some, these parallels were too striking to ignore. Was this object simply another comet, or was it a vessel of ancient chemistry, an archive of molecular evolution preserved across billions of years? Others entertained more speculative theories. If Atlas had wandered through multiple star-forming regions over its lifetime, could it have accumulated complex organic layers from environments completely unlike our own might? Some of these environments have hosted primitive life. And if so, could any traces, however microscopic or incomplete, still exist within its icy matrix? Of course, such ideas remain in the realm of hypothesis, not evidence. But hypotheses are unavoidable when every new observation challenges conventional explanations. Take, for example, what happened after perihelion. Most comets peak in brightness near their closest approach to the Sun, then gradually fade. Atlas did fade. Its main anti-sunward tail shortened and its coma dimmed, but then something extraordinary emerged, a distinct growing sunward-facing tail. How could a tail point toward the Sun, the very source of the solar wind that pushes cometary material away? Was this merely a plasma phenomenon caused by magnetic interactions? Or did it indicate something more unusual? Perhaps the presence of an internal magnetic field strong enough to deflect particles in unexpected directions. The possibility of a magnetic field around Atlas may seem implausible, yet recent analyses suggest otherwise. Magnetite. A magnetic mineral forms naturally when water interacts with iron and nickel under certain conditions. If Atlas's global cryovolcanism produced magnetite in large quantities, could its surface have become magnetized? Could this explain not only the sunward tail, but also the wave-like structures observed in its jets? Structures reminiscent of plasma filaments shaped by magnetic tension. If Atlas truly possessed a magnetic sheath, however weak, what implications would that hold? A magnetic field would shield organic molecules from destructive radiations, increasing the chance that complex chemistry could survive the journey between stars. Does that mean objects like Atlas might act as natural carriers of molecular information across the galaxy? This is where scientific curiosity blurs into philosophical inquiry. Is the universe quietly distributing the components of life through drifting bodies like Atlas, seeding star systems the way winds scatter spores across continents? Or is Atlas simply a geological relic, remarkable but ultimately ordinary, merely reflecting the chaotic diversity of materials produced during the formation of planetary systems? As Atlas moves farther from the Sun, the questions grow sharper. Why did its brightness surge begin so suddenly, so uniformly? Does its 16-hour rotation truly point to a global event rather than localized activity? And why does the chemical signature of its coma resemble meteorites from the early solar system, even though it was born in another star's cradle? Coincidence? Or evidence that the building blocks of life are produced universally, wherever water, metals, and energy converge? Even the timeline of its journey invites speculation. For at least 10 million years, Atlas drifted undisturbed. What was it doing during that immense silence, passing through nebulae, skimming the outskirts of ancient planetary systems, absorbing material from supernova remnants? How many cosmic environments etched their chemical fingerprints into its layers before it arrived here? And now, perhaps the most intriguing question: why now? Why is Atlas reaching the Sun at a moment when humanity finally possesses the instruments to study it in unprecedented detail? Pure coincidence? Almost certainly. Yet the coincidence does not diminish the profound significance of this encounter. For the first time, we are watching an interstellar object undergo a chemical and physical transformation, triggered not by its home star, but by ours. What does that transformation reveal about the nature of matter drifting between star systems? Some propose that Atlas may represent a missing piece in the panspermia puzzle. Others consider it a living laboratory, showing us step by step how simple molecules might evolve into the precursors of biology. And some inevitably wonder whether its activity hints at something engineered or deliberate. But that last speculation, while fascinating, lacks evidence and remains confined to the realm of imagination. Yet imagination has always been a companion to discovery. And with Atlas, imagination feels less like indulgence and more like necessity. Because the closer we look, the stranger this interstellar visitor becomes. And the more it reveals, the more it forces us to ask a question as old as humanity itself. Where did life begin? For now, Atlas continues its outbound journey, still active, still shifting. But the greatest mysteries may lie not in what it has already shown us, but in what it will leave behind as Earth crosses its debris stream next year. As Atlas drifts farther from the Sun, cooling and quieting, another question rises to the surface. What will its passage ultimately mean for us? Not just scientifically, but existentially. Because for all the data collected so far, the most intriguing mystery may not be what Atlas is doing now, but what it has already left behind. Earth will cross the region of space where Atlas erupted during its perihelion, a debris field infused with dust organics and volatile fragments released during its global cryovolcanic awakening. What exactly lies within that cloud? Are these particles chemically ordinary, or do they carry molecular structures never before encountered in our solar system? Could they contain primitive organic chains shaped by environments older than the Sun itself? And if traces of prebiotic chemistry fall upon Earth, will they simply burn up in the atmosphere? Or might they be detectable, offering a rare chance to examine interstellar matter delivered directly into our grasp? Some scientists hope for such a scientific windfall. Others raise a more unsettling question. Should we be cautious about unknown materials from beyond our solar system entering Earth's environment? Of course, there is no evidence suggesting danger. Organic molecules are harmless. Simple compounds cannot infect or alter biology. But still, the question lingers. What if life elsewhere operates on principles we do not yet understand? Could Atlas harbor structures that challenge our definition of what is alive? Or is that speculation wandering too far from reason, inspired more by imagination than by evidence? Yet isn't that how many discoveries begin with uncomfortable questions? The panspermia hypothesis, once dismissed as fringe, grows more plausible with every new observation. Meteorites already brought amino acids and sugars to early Earth. Why couldn't interstellar objects like Atlas play a similar role across the galaxy? Perhaps life is not a rare accident, but a cosmic routine unfolding wherever water metals and energy coexist. If so, objects like Atlas might be the galaxy's gardeners, scattering seeds across star systems, leaving molecular fingerprints wherever they pass. But even if this is true, what does it imply about the origin of life on Earth? Could our earliest building blocks have come from something not unlike Atlas, an ancient wanderer carrying the chemistry of forgotten stars? And if life did not begin here, but merely grew here, how does that reshape our understanding of ourselves? Atlas also brings forward a more radical question. Is it possible that interstellar objects are not just passive messengers of chemistry, but active participants in planetary evolution? Could impacts from bodies like Atlas have triggered bursts of biological potential on young planets, or even selectively delivered compounds necessary for the transition from chemistry to biology? Each possibility stretches the imagination, but none breaks it. The more we study the universe, the clearer it becomes that complexity is not rare, it is inevitable. Still, a more conspiratorial thread of thought has emerged among those who follow Atlas's every update. They note the timing, a highly anomalous interstellar object passing close to Earth at a moment when humanity has the tools to study it in unprecedented detail. Is this coincidence or part of a larger cosmic pattern? Could ancient interstellar travelers occasionally serve as markers or reminders of the larger universe we inhabit? Could they even be mistaken for probes or relics from long-dead civilizations? There is, of course, no evidence supporting such claims. Atlas behaves according to physics, not intention. Yet the mystery persists because Atlas does not behave like anything we have seen before. Its chemistry is strange. Its activity is global. Its magnetic behavior is confounding. Its history is vast, older than the Earth that now studies it. And perhaps that alone is enough to fuel speculation. When confronted with something ancient, foreign, and inexplicable, human instinct reaches for meaning. But maybe the real meaning lies in the questions Atlas forces us to ask. What if the universe is filled with objects like this interstellar archives drifting unnoticed through the void? How many of them carry materials that could, under the right conditions, spark life on young planets? And if life can emerge from such simple chemistry, does intelligence inevitably follow? Or are we an anomaly? A rare outcome in a universe dominated by silent wanderers like Atlas. As Atlas moves toward the outer solar system, heading eventually back into the deep dark, it called home. For millions of years, we must ask one final question. What else has the universe been sending our way that we failed to notice? Before Oumuamua, we had never identified a single interstellar visitor. Now, there are 3 within a decade. Are interstellar objects common, merely overlooked until recently? And if so, how many carry chemical clues that could transform our understanding of life? Perhaps Atlas is not extraordinary at all. Perhaps it is typical, a representative sample of cosmic material drifting between stars. If that is true, then the extraordinary part is not Atlas itself, but what it implies that the galaxy may be teeming with the processes necessary for life. Atlas will soon fade from our skies, becoming only a point of light, and then disappearing entirely. But the questions it raised will linger. Did we just witness an ancient mechanism of cosmic chemistry awakening under our sun for the first time in millions of years? Did we observe the same set of conditions that may once have shaped our own biological origins? And if life is not unique to Earth, but born from the chemistry woven into objects like Atlas, what does that make us children of the solar system or children of the galaxy? In the end, Atlas reminds us of something profound, that the universe is far older, stranger, and more interconnected than we imagine. And somewhere out there in the dark, between stars, countless other wanderers may be waiting for their moment to awaken.